Hey guys, Mr. Backwork here. In this video, we're going to look at multiplying square roots. As we're looking at doing our multiplication, there's a few steps that we're going to follow. And first, we're going to look to simplify down our square roots or our radicals first, if it's possible. Now, this isn't a 100% necessary step, but sometimes as we're multiplying some of these radicals together, we might end up dealing with some larger numbers that can be difficult to multiply together. So by simplifying down the radicals, that usually makes the numbers smaller and easier for us to work with. Now, after we do our simplifying, the next thing we're going to do is the actual multiplication. And we'll talk about what that looks like in just a minute here. Now, as we do that multiplication, there might be some more simplifying that needs to happen at the very, very end. So after we do the multiplication, we want to check to see if there's any more simplifying that can happen. So in this first example, we've got the square root of 2 times the square root of 5. And our first step said that we wanted to look to see if we could simplify down our radicals. So we want to think about making our factor tree. Well, the only factors of 2 are 2 and 1. There's no pairs there, so the square root of 2 isn't going to simplify. And the same thing is true for 5. The only factors of 5 are 5 and 1. No pairs there, so we're not going to be able to simplify those down. So we're going to move on to the second step, which says do your multiplication. When we are multiplying radicals together, if we're multiplying two radicals, what we want to do is we want to multiply the two numbers together that are underneath the radical, but then keep the radical on our answer. So we're going to take the 2 times the 5, but we're going to put all of that underneath one square root. And 2 times 5 is going to give me 10. So I get the square root of 10. And then my last step said check to see if you can do any more simplifying. Well, the only factors of 10 are 2 and 5, and there's no pairs there, so the square root of 10 will not simplify down at all. So that's our final answer. Now, as we look at this next one, we've got the square root of 6 times the square root of 8. So the first thing I'm going to do is check to see if we can simplify this down. So 6 only breaks down into 2 and 3. There's no pairs there, so we won't be able to simplify that down. Now 8 is going to break down into 2 and 4, but 4 breaks down into 2 and 2. Here I see that we have a pair of 2's, so I'm going to take a 2 out of my radical, and I've got this other 2 left over, so I'm going to leave that underneath my radical. Now I've still got that square root of 6. Now as we're doing this one, thinking back to what we did on the previous example, when you're multiplying two square roots together, we're going to multiply the numbers that are underneath the square root. So I'm going to focus on the 6 and the 2 that are underneath the square root first. We're going to multiply those together because they're both underneath the square root. But then we've got this extra 2 that's in front of our square root. So I'm going to put that 2 in front of my square root. Now underneath the radical, 6 times 2 is 12. So I get 2 times the square root of 12. But then our steps said that we wanted to check to see if we could reduce this down any further. So 12, well, we can think about that as being 6 times 2, since that's what we just did earlier. 6 is 2 times 3. So if we look, by doing that multiplication, we created another pair underneath our radical. So we've got a pair of 2's that we can take out along with that other 2 that we already had in front of our radical, and we're going to multiply those together. But now this 3 doesn't have anything paired up with it, so it's going to stay underneath the radical. Now multiplying those 2's together that are in the front, 2 times 2 is 4. So for our final answer, we're going to have 4 times the square root of 3. Now for this last one, we're multiplying 3 pieces together, and the rules are still the same. We want to check to see if there's any simplifying that can happen. We can't simplify down 2 at all. We can't simplify down the 3, and we also can't simplify down the 7. So there's no reducing that can happen here. So now we're going to move on to the multiplication part. Before, when we were just multiplying 2 square roots together, we said we were going to multiply the numbers together. The same thing is going to be true here, except now we've got 3 numbers that we're going to multiply together underneath our big radical. So 2 times 3 is 6. 6 times 7 is 42, so we get the square root of 42. And then we would want to think about if we're able to reduce down this radical at all. Well, 42 is just 6 times 7, 6 is 2 times 3, and there are no pairs in here, so we're not going to be able to simplify this down at all. So the square root of 42 is our answer on this one. Now this one looks just a little bit different because each one of our radicals has a number in front of it. First thing I'm going to look at is I'm still going to look for the simplifying. 7 can't be simplified down at all because 7 is just 1 times 7, and there's no pairs there. The square root of 5 can't be simplified down either because the only factors of 5 are 1 and 5, and that doesn't give us any pairs. Now, when you've got numbers in front of both of your radicals, when you do the multiplying, you want to multiply those numbers in front together as well as the numbers underneath the radical. So in the front, 5 times 3 is 15, and underneath our radical, 7 times 5 is 35. And then once again, we want to check to see if we can reduce down our radical at all. Well, for 35, the only factors are 7 and 5. That's what we just did earlier. There's no pairs in there, so that's not going to be able to simplify down. So this is going to be our final answer, 15 times the square root of 35. For this next one, we've got negative square root of 6 times the square root of 12. As far as this 6 goes, if we try to break it down, it's just 2 and 3, so there's no pairs there, so that one will not simplify down. For this 12, we can turn 12 into 2 times 6, and then 6 is 2 times 3. So here we've got a pair of 2's, so we can take a 2 out of our radical. This 3 doesn't get paired up with anything, so it's still underneath the radical. And then we still have this negative square root of 6 that we're multiplying by this stuff. Now, having that negative in front of our square root of 6 is really like having a negative 1 in front of there. So now this one looks kind of similar to that last one that we just did. If we take negative 1 times 2, that's going to give me negative 2. Underneath the radical, if I take 6 times 3, that's going to give me the square root of 18. And then, like we've been doing this whole time, we want to check to see if we can simplify down this radical. Well, 18, we just did 6 times 3, but 6 reduces down into 2 times 3. So I see that we created a pair of 3's that we can take out of our radical. Now, don't forget, we already had a negative 2 out in front, so we need to multiply those together. Underneath our radical, this other 2 didn't get paired up with anything, so it stays under the radical. Now, when we take the negative 2 times the 3, that's going to give me negative 6, and then we still have this square root of 2 attached on the end. So we get negative 6 root 2. Now, for our next example, we've got the square root of 21 times the square root of 14. Now, as we look at trying to simplify this down, 21 is going to be 7 times 3, so that's not going to simplify down at all. And 14 is going to be 7 times 2, so that's not going to simplify down at all either. But I want to approach this one just slightly differently so that we have maybe an alternate strategy as to how we can go about multiplying these radicals together. We made these factor trees to check to see if we could simplify down our radicals, and we didn't notice any pairs in each individual radical. But if we look at the radicals kind of as a whole, I notice that we've got a 7 over here in our first radical, and we've also got a 7 over here in our second radical. So that creates a pair of 7's. Well, like we've been doing with simplifying down radicals, anytime we find a pair in our factor trees, we want to take that out. The same thing is actually going to hold true here. So because I see this pair of 7's, even though it's not necessarily in the same radical, multiplying these together is actually going to allow us to take that 7 out of the radical. And then we've got this 3 and this 2 left over, which we're going to put back together underneath our radical. And 3 times 2 is going to give me 6. So multiplying these together and reducing would give us 7 root 6. Now we can also use that strategy if we've got more than 2 radicals that we're multiplying together. So 36 is going to be 6 times 6, but 6 is 2 times 3. And this 6 is 2 times 3. For the square root of 8, that's going to be 4 times 2, but this 4 is going to be 2 times 2. And then lastly, with this 2, it's just a 2. I'm still going to put a branch down for 2, just so we can check all of our branches. So I notice, as we start going through all of our different branches that we've got here, I see that we have one pair of 2's, so I'm going to take a 2 out. I see that we have a pair of 3's, so I'm going to take a 3 out, and we'll have to multiply those together. As we look a little bit further down the line, I see that we have another pair of 2's, so I'm going to take another 2 out. And then I see that we have one last pair of 2's, so I'm going to take one more 2 out of my radical. Now, if I notice, the ends of all of my branches got paired up with something, meaning that there are no leftovers to go back together underneath my radical. So I don't need to have a square root in my answer. So I'm just going to do the multiplying that's laid out for us here. 2 times 3 is 6. 6 times 2 is 12. 12 times 2 is 24. So we get 24 as our final answer on this one. Just a couple more examples that we're going to run through. So here we've got the square root of 2 times the square root of 2. When you're multiplying these two radicals together, we would multiply the numbers underneath the radical. So 2 times 2 is 4, but then we keep the square root on it. Now, hopefully we can recognize 4 as being a perfect square. The square root of 4 ends up being just 2. So what I want you to notice about this is we multiplied the square root of 2 by another square root of 2, and we got 2 as our answer. So what's happening here, if you multiply a square root by itself, the answer you get is just going to be the number that was underneath your square root. So because each one of these had a 2 underneath the square root, our final answer was just 2. Now if we check this next one, we've got the square root of 8 times the square root of 8. Well, 8 times 8 would be 64, but we're supposed to square root all of that. And again, 64 is a nice perfect square. The square root of 64 is just 8. So we took a radical times itself, and the answer we got was just the number that was underneath the radical. Now this next one looks just a little bit different. It says the square root of 7 squared. But we have to remember that squaring something really means times itself. So this would really say the square root of 7 times another square root of 7. And 7 times 7 is 49, and if we square root 49, that's going to get us back to just regular 7. So this one didn't necessarily look like we were multiplying the square root of 7 times itself, but because of that squared power, that's what it really means. So the square root of 7 squared just gave us 7. That's going to be it for this video. Thanks for watching.